Perfect. Let's do this.
Let's do this. So we are live. We're going live. We are definitely live. Hello, everyone, and welcome to live stream number 78 of the Data on Kubernetes community. It is good to be with you here today. It is August 24th. Exciting day to be meeting, to be learning about Kubernetes. Just as a quick reminder for all of you folks out there, we've done 78 live streams, and we're about to do our second KubeCon, our second co-located event in KubeCon, and you can be a part of it. I'm going to leave the CFP right here, all right? If you haven't checked out the CFP, we are looking for end-user focused talks where folks can talk about working with stateful workloads, running stateful workloads on Kubernetes. We mean databases, we mean operators, we mean networking, we mean analytics, different things. If you have questions, you can always ask in Slack. By the way, if you're not in our Slack, why are you not in there yet? Also, make sure you click like right now on this video and subscribe to our YouTube channel. Always got tons of stuff coming out. Now, today we have a very, I'm not going to lie, a pretty controversial topic, all right? I always give this example. About 5 years ago, I was working in a software development company, and I remember when we got to the battle between TeamCity versus Jenkins, it got so ugly, all right, talking about tooling, that some people were threatening to leave the company. Some people really got their feelings hurt. It gets really, really intense. We start talking about tools, so people's sort of sensitivities come out of the woodwork. Some people get really attached to a tool. Our guest today, Javier Ramos, very bravely wrote a very cool post that I'll be linking in the chat as well, so you can check that out. Talking about a lot of tools on Kubernetes in 2021. Right now, this article came out a month ago. First of all, Javier, very, very nice to have you with us today. Can you tell us a little bit about yourself, how you started working with Kubernetes, and then a little bit about how you got into this world of tooling?
Okay, sure. So definitely, yeah. I wrote this article based on my personal research, especially because over the years, like I've been in software industry for a long time, and the last, let's say, 4 or 5 years, like most of us, start looking into Kubernetes as a way to basically simplify the basically this big monolith mess that I was used to. I come from the Java enterprise world, SOA and all this. So I don't know if so some of you may be old enough to remember those days. And then I got into more cloud native microservices, domain driven design, all this, especially big data and DevOps. That's could be my profile could be summarized with that. Well, first I don't like to, you know, when they told me, well, are you a backend developer, front end? I love React as well. So I'm a bit of everything, right? So I don't like to just be part of something. I like also machine learning and all this. So that will be my background. Then I got into DevOps and work on many clouds. I work from very small startup, like 30, 40 people, to big companies. I was working for IBM, Oracle, and this type of companies as well. So I have those experience in different clouds, from GCP, Azure, and AWS as well. So that's basically my background.
Okay, no, very, very good. Now the thing is, you in this article, which I've linked down the YouTube chat, so folks want to check that out. It's quite an exhaustive list. I mean, like there's a lot of stuff in there. Obviously today we're not going to be able to get to all of that, but I'm just curious, like because for a lot of folks that are starting out with Kubernetes, it gets really overwhelming. You know, I think there are lots of memes and, you know, showing like, well, if you want to learn this, first you have to learn these other 6 things. In your case, was that similar, or how was your learning journey then with Kubernetes, and then also particularly with the tooling?
Exactly, you're right. It all started talking with a friend, which is a front-end developer, and he was complaining how many JavaScript frameworks there are. And I was like, okay, hold my beer, wait for it. That now it's coming Kubernetes. Yeah, it's true. There are way too many. I think Kubernetes, got the first step right, the right level of abstraction, which is kind of low level. So it's very easy to build on top of Kubernetes, and that's why there's so much tooling available. And one thing has to do also with the fact that there are very similar products on the market, and mainly comes with, especially with the Kubernetes adoption, what I've seen over the years is that this whole thing, I call it, I don't know if it's a real term, I call it accidental complexity, which is when basically you go and build something that is already out there because you don't know about it. So you tend to complicate a lot more the problem. So I've seen it many times that every organization build their own orchestration tools for orchestration pipelines, or monitoring tools, or CI/CD, especially with their own custom Jenkins. So lots of things when there's a product out there. So my research for this article is my goal to basically remove this accidental complexity, because how do I do a multi-tenant deployment, right? Should I go and start implementing my own network policies, start creating all this, or there's a tool that already does that for me, right? So that was my why I started looking into these tools, and I wrote the article based on my research.
Very, very good. Now, when it comes to tools and preferences, what do you think generally are factors that influence those things? Is that my boss likes this tool, or I saw this talk in KubeCon, so I like that one? Where do these sort of preferences, in your opinion, generally come from?
That's a good question. You'll have to always look at pros and cons. One thing I always ask is, somebody comes with a proposal, let's use this tool. I always ask, where are the alternatives, right? And you saw that my article is divided on this the tool, this is the one I know, but there's these alternatives that, that you should look. So first of all, always have compare, don't go with the first one you find because you saw a video or something, compare what's out there, and then align that to your company principle. For me, it's very important each company have these high-level goals, how the company works in terms of how risk adverse are. People make fun of Google because they're killed by Google project that they, so many projects go wrong, but that's a company that takes a lot of risk, right? And some of them become really, really successful, right? But not all the companies can afford to be that. So from the top of the company, I think the first step is define, at the CEO level, right? Define what's your attitude, how, and then translate those company values into architectural principles. Kind of the CTO will manage that and create that type of things. What type of approach? Are you cloud agnostic? Are you investing 100% in Kubernetes? These are big decisions for the whole company, right? Or are you going to always be attached to one cloud, which is much easier? So these type of decisions, right, in terms of approach. And then architects after that, they'll create more specific patterns, use this or that, use this tool. And then if you have that background, you have from the company values and the architectural principles, then it's a lot easier to choose a tool. But if there's no consistency in the organization, it becomes really hard to choose one or the other.
I think that's a really good point. And so when approaching the decision-making process, whether it's one or the other, is going back and saying, well, what do our values tell us? And how does this architecture align? I think it's a really, really good question, because it is also true. People that work on tools make a lot of noise about it. There's a lot of, you can call it marketing or content or whatever that's going out about it. So then there's this sort of pressure and immediacy, or what's used in marketing very often, of FOMO, fear of missing out, that then kind of pushes people, no, we have to decide right now, or we really have to make a decision. When, like you said, maybe taking a step back, looking at, okay, what kind of guidance or governance do we have regarding all of our decisions, whether it's with tools or not, and looking at values. I find that to be interesting. Anyway, I don't want to take, I could talk about this all day. What kind of tools do we want to look at today? What do you think are the things that are new, that are hot, that are extra relevant? What do you want to take a look at today?
Exactly. So the idea is I have a few slides. We're going to review the tools I talk in the article. If you think about it, these are basically the tools I think either are very important. So, and those are gonna mention very slightly. I'm gonna say, hey, use Helm, but Helm is quite popular already, so I'm not gonna spend so much time on that. I'm gonna talk mainly on the ones that I think they are less famous, but they have a lot of potential to become the next big thing. And especially focus, I'm very fond of GitOps, right? So most of these tools, they follow that. And that's why in the alternative, you say, maybe I put a tool and there's alternative that is maybe as good, but I put it there because it's not as GitOps friendly as the other. So for me, I love to have everything as code. Even the architectural decisions are in Git. So the same principle for me, like REST was successful because you already have this common language, get, batch, put, and all that. I think with Git, with the PR request and review and the history and the decision process, you can leverage on that as well and all these tools leverage on that, or most of them, which are good. So that's why most of them, they are GitOps friendly.
Okay, that's good to know though, as a sort of, that you're coming out with this perspective, as everybody has their own background and perspective. That's fine. If you want to share your screen, go for it. We can start taking a look at these more in depth. Just once again, as a reminder, folks, feel free to put any questions, doubts, suggestions that you have in the chat, and we'll deal with those accordingly.
Exactly. Perfect. Let me know if you can see my screen.
Yep.
Perfect. 1 sec, because I was clicking share.
Nah, no worries, man.
Okay.
Yeah, it's okay.
Okay. Hopefully now we'll load.
Yep. Should be getting there soon.
Yeah, 1 sec. I don't know why it's the full screen not fully working.
Oh, that's okay.
Let me reload this.
It's funny. We're always talking about these very advanced technologies, but then the problems that we have with PowerPoint presentations and things like Zoom, it's always incredible.
We always run into these issues, and then but you can see it now on my screen, right?
Yep, got it.
Perfect. Okay, perfect. So let me see. Okay. So the agenda is very simple. There will be a quick introduction, then we'll go to see the tools. And if we have time, we'll go into the Q&A. Again, about me, I already talked. So I've been in the industry for quite long. My background is Big Data and DevOps. If you share these slides later, and then these are my contacts. If you want to follow me on Twitter or subscribe to my articles in medium.com, you can click those links, and probably will share the slides after. Okay. And this is more or less what I was talking. I think most companies tend to reinvent the wheel a lot, especially in DevOps and Kubernetes. And some examples are orchestration tools, CI, security. I've seen many companies doing the same thing over and over again, where there are tools out there that does that. And that's what I call this accidental complexity. It's not they do it on purpose. It's just engineers, they want to design things. So the first idea is, I can do this by myself. So they go and do it, and they spend sometimes months, if not years, doing something that is already out there. And especially in Kubernetes, because it's open source friendly, people tend to release it, and most likely somebody has done this before. So always do your research. So this article is based on my own research. Again, I will focus again on the newest tools, especially the GitHub friendly tools. And what my goal is to answer always the question on how can I do X in Kubernetes, right? Especially for people who are used to do certain things in other platforms. So, and they're wondering, how can I do this in a Kubernetes friendly way? All declarative nature and so forth. And again, just a quick disclaimer, this is just my own research. I'm not an expert on any tool. And some of them I barely touch, some of them I use quite a lot. I have expertise, but if you see there a tool, feel free to stop and make comments. Let's collaborate here. If you have, or know another tool that may be similar, that happens when I released the article. I got a lot of feedback, and some they suggest other tools, and I've been updating it. So which is really cool. So I appreciate your comments, suggestions, and in the Q&A, feel free to suggest other tools, or if you are probably there's some people in the audience that may know a lot more about some tool than me. So feel free to also make comments and suggestions if you have experience with any of these tools. Okay, so now we will go really fast through all these tools because we don't have much time, and there are, I think, over 20 of them. So let's start with the simple thing, how I run a Kubernetes cluster on my laptop. For me, the best option is K3D, which is basically a wrapper around K3S, it was created, I think, by Rancher. I think it's the company behind it, that built a very lightweight version of Kubernetes based to run on IoT and others, basically edge devices, right? And then it's a wrapper using Docker, so then you can run it very easily on your machine. So it's very lightweight and fast. Again, the alternatives kind is quite popular now, and then Minikube and MicroKS are all the alternatives. All are used to run a local Kubernetes cluster. Okay, my recommendation is create again the K3D because it's very lightweight and easy to use. Then the next thing is, using kubectl. There are lots of plugins available. So I use Crew to search over 145 plugins. I recommend always to use Kubernetes, basically to be able to switch between namespaces easily without typing namespace this, namespace that. So, and Context does the same, especially when you have several contexts. So you manage several clusters. It's very useful. So this is another tool for me essential in Kubernetes, and these are for me must-haves. Then we move to IDEs. Some people don't like them, but if you like IDEs, Lens is built for Kubernetes, right? I think I can show really quick how does it look, but it has so many options. You can see your workloads, the number of pods running. You can have here pin your different clusters. You can see your any jobs, the configuration, the network storage, events. Configure pretty much everything, and it's very fast, and the UI is really, really nice. So I really, really recommend this idea. If you are the type of ops guy that writes terminals, then K9's this approach is also a very lightweight terminal. So it's all in the terminal, and it's also really, really interesting. So just your choice. If you want a full UI, I think Lens is based on Visual Studio Code, if I remember properly. And K9S is just a terminal. Also really, really good. Again, if you have any questions, let me know as well. Then, of course, Helm is another must-have. You need package manager in Kubernetes if you are doing something serious in Kubernetes, right? Again, it has the templating engine. Let's not get into what Kubernetes is. It's very important. Onto what the Helm is. Helm is mature, has lots of predefined chart support, and is widely used. So I'm not gonna get into details. I only want to mention Customize, which is another approach. It's not exactly as Helm, right? But it's another way to deploy apps. And I haven't used Customize, but I heard really good things. So if there's any Customize user that wants to talk about the difference, welcome. But also have a look to Customize before jumping into Helm as well. And then moving to GitOps. So as I told you, I love GitOps, and Argo CD is basically a tool for GitOps, right? Again, I like to store everything as code, follow the same principles, keeping one source of truth. So what Argo CD does is just watches your repo, and if you want to make a change, right? So for example, it's very common to have a repo per environment. So you have your dev, your production cluster. So you have different environments. And then what you do is, if you want to make a change in production, you open a PR, the same thing that you do, and if you open a PR, it gets reviewed, then it gets merged, and that's how it works. And you have that history, that notion of audio. It's easy to audit, to trace, and so forth. And Argo CD can monitor basically Git repos, but can monitor any repo. That means that it can monitor your Helm charts, repo, anything, right? So another approach, if you are using Helm, is to have your source code, right, with your dev cluster. So you have your definitions there, and basically you say, I want the app that is deployed on this Helm repository. So when there's a new version of the chart release, deploy it. So for example, you could have your CI/CD pipeline that then promotes a version of a Helm chart, gets deployed, and Argo CD automatically detects a change, watches that, and makes the change in the cluster. So you don't need to do anything imperative. So for me, the key in Kubernetes is that declarative nature, that you have these control loops that check and control that what's running on the cluster matches what is in the Kubernetes etcd database. For me, that's awesome. It's the best thing ever. And now Argo CD extends us to a Git repo, and that's the same thing. It's always constantly in a loop, checking the repo. Any changes is synchronized with the cluster. So if something is deleted from the definition that you have in YAML in your repo, then it will delete it as well from the cluster. So for me, this is awesome. And again, as I mentioned, it's implemented as a Kubernetes controller, which continues monitor applications and basically comparing the state. That's basically what Kubernetes does with pods. Now you do it with pretty much everything, because if you use, for example, any extension, like we saw, now we are going to see all these tools that are GitOps friendly. What I mean by being GitOps friendly, it means that they can integrate with Argo CD, and Argo CD can watch them. So for example, if you have batch job or workflows and use Argo workflows, which use their own custom CRDs, you can actually put them there, and Argo will also watch them and release them as well and detect them in the UI, and you'll have your jobs there as well. The alternative to Argo CD is Flux, which is very, very similar. I think there were a lot of issues didn't work well in the previous version, but I heard good things about the latest version. I haven't used it, but I heard it's very similar. So I don't have strong opinions about it. So if you are not using, my recommendation, Argo basically is a bunch of projects. We'll talk about Argo rollouts, Argo workflows. So my suggestion, if you are using Argo products, use Argo CD. If not, really consider Argo CD and Flux. Both are very similar. So just compare the small difference and make your own decision, because these ones are really close, these two. If we continue with Argo, of course, I have experience with all the products. So again, if you use Argo CD, Argo Workflows integrates very well, which is basically an orchestration engine. And this can run, actually, Argo Workflows can substitute Jenkins. It can run actually CI/CD pipelines. It can run data pipelines as well. It can be used, as a cron job to run batch jobs as well. So everything that requires this type of workflows, it's really, it's used, and the cool thing is it uses their own custom CRDs. So everything is defined as YAML, everything is defined as code in your Git repo. Argo CD can watch those changes, right? So it's integrates really well with GitOps principles, meaning that if you want to change basically a job that runs at midnight to something else, you go to Git, create a PR, and that follows the same things. All your configuration is in the code. That's awesome. And again, similar to whoever uses Airflow, it's the same, but it's the problem of Airflow is that basically you have to manage it the way it scales. It's not very scalable, and Argo Workflows is fully Kubernetes, so it takes advantages of all the highly available offers retries, cron-based jobs. It can track input and output, and much more. And then integrates with Argo events. So now Argo Workflows and Argo events were separate projects. Now they've been kind of tightly integrated. Argo events adds the kind of event-driven thing, actually close to serverless type of things, where you can integrate with third-party services like Kafka, webhooks, queues, deep storage. So you can react to something upload to S3, and that can trigger a workflow. So instead of being cron-based, you can create these things that some file gets uploaded, or there's some ingestion going on, goes into the data lake. Now you can react and run in many pods, because our workflows is very scalable. It will create lots of pods, so it can scale very well, and can react to these things, read from the file that was uploaded, do some ETL, store it somewhere else. So it's very good to do data pipelines. So alternatives to this are, again, Argo Workflow is very generic. I could be used also for ML pipelines, CI/CD pipelines. But if you just care about ML pipelines, there's Kubeflow, which is a Kubernetes MLOps type of tool. And that's to basically do machine learning pipelines for the whole model lifecycle. And if you just want CI/CD pipelines, Tecton is another tool that is just focused on CI/CD. Where Argo Workflows is more generic. It's a DoK, and you set dependencies, and you can do pretty much anything you want. Okay, let's see how we are doing with time. Yeah, I'll try to go fast. Another great tool, again, I've been doing this for a long time where I have my pipelines and I have my build. I have to build my Docker images. And one thing I will do is run it inside a Kubernetes cluster or inside a container. And then you have the problem of Docker on Docker, right? This big issue that you tend to do this type of things where you mount the Docker sock. This is very ugly. It's not safe. It's not secure. I have to admit I've done it in the past because I had to run my tests. Those are integration tests. So they bring a Postgre database or a Mongo database. And I need to run containers inside containers, and this is really ugly and things like that. So Kaniku allows you to basically do those images, building images within Docker, so within Kubernetes. So if you need to build Docker images inside Kubernetes, use Kaniku. It's a Google product, and it works really, really well. For me, unfortunately, I discovered this after I've done the bad way. And I regret, but if you still have time, have a look before you start building your containers in the wrong way, because it removes all these issues regarding building images inside Kubernetes. So definitely a must-have for building images in your CI/CD pipelines. Okay, this is another one. I say another beast in its own. It's a service mesh that could. We can talk about 1 hour about service mesh, but I like to summarize saying that service mesh is basically used to run microservices. That's overly simplified, right? But basically, as this, it allows you to add these capabilities like observability, traffic manager, security. So everything that you usually put in your project, like, oh, I need to authenticate, I need to control errors, I need to do some traffic management, I need to monitor, all that basically is done in a proxy that Istio injects as a sidecar in your pods. Again, it's much more than that. It offers a gateway, it offers so many things. It doesn't allow, but basically, if you run microservices in Kubernetes, consider using a service mesh. Istio is the most popular, but also I don't have the preference. There are alternatives. I put them there. Linkerd is also quite famous and super lightweight. And Consul is one that I look more, especially when you want to stand the service mesh outside Kubernetes, right? It's still, you can do it, but it was meant mainly for Kubernetes. Or at least is some people may not agree on this, yes. It's not meant only for Kubernetes, but I think Consul integrates more with hybrid type of environments where you have on-prem Kubernetes, but everything is controlled within the same networking control plane of the mesh. So I also like Consul in that way. Again, so just bear in mind, if the idea is, if you are building microservices and you have complex services, of course, you need to use Helm charts, but also consider adding Istio. It will simplify things and remove the duplication. Moving again in the Argo project type of Argo has really, really good projects. So I'm a big fan of all of them. And one thing, Kubernetes, the default strategy when you deploy something in Kubernetes is the normal rollout process, right? And the way it works, it's very simple. So Kubernetes will create another replica, bring on one pod, run the readiness and liveness prod, the health checks, and if everything is fine, then it moves to the next pod and so forth. So you have this type of zero downtime deployment, which is great. Also automatic rollback if it's not healthy, but it's not enough, because basically if you want to control the traffic that goes into the release, if you want 1% of the traffic, you cannot do that, or you have to have lots of replicas. It's not super complex. Actually, for me, Argo, the Kubernetes normal rollout is not enough to do a continuous deployment. It can do it, but you don't have that trust on your automation. For me, the idea of, for those who are not aware of the difference between continuous delivery and deployment, is continuous delivery, it needs a manual step. And if you need a manual step in continuous delivery, it's because you don't trust fully your automation. right? And it's true that when I do deploy something in production Kubernetes, the normal rollout process is not good enough for me to have that confidence that nothing is going to break. Of course, you should follow continuous integration, so have small changes, so nothing big will happen. But the idea is have more advanced strategies. And Argo rollouts adds to Kubernetes all these advanced strategies, especially Canary. That's basically where I see the potential. I can also do blue-green strategies, but the idea of doing Canary with experimentation is the strongest points of Argo rollout. So how does it work? Very simple. So you'll have your microservices, you do a deployment, and you create a plan in Argo rollouts, right? Where, again, your development teams and you as a developer, you should have lots of metrics, not only on the node or in the pod, like error rates or that. So most of these metrics, if you use Istio, you'll have them for free, like error rate, latency, and so forth. You can have your own custom metrics that you add into your service, depends on what it does. So observability is key. Like for me, I'm fan of stop testing and get good observability, and then you won't need so many tests, right? So you create really lots of metrics, everything detailed, and then you create this plan that you send to Argo rollout. Again, YAML, everything can be stored in code, GitOps friendly, and you said, okay, I want 1% of traffic, wait 5 minutes for Prometheus to gather the metrics of this 1% that is going there, and compare to, the real production environment, and see if there's, and then you put rules, whether it passes or not. So for example, if the latency has increased or the error rate has increased, then Argo rollout will roll back the deployment. If not, we'll move to 10%, 20%, and you set up this experiment. And that's called experiments because they wait for metrics to be captured, and then you compare the features. And that will give you the confidence that, yes, I can go to production because I can detect anything. And when somebody says, I'm doing continuous deployment, I'll be, cautious to say, well, really, if they are not using this canary, because either they are a bit, let's say, crazy that they are going to production with testing, without testing properly, or they're using Canary. Canary for me is the enabler of continuous deployment, right? Because it gives you that trust. You trust observability. And so with Argo rollouts, you can do this type of Canary releases, which are awesome. It's very hard to see them in real world, again, and that's why many companies, they still do this type of continuous delivery, where there's the manual step, you test it by humans, and that's it. And for me, the problem is observability. So get good metrics, and then you will convince your manager that you can deploy to production without human intervention. Alternative is Flagger. Again, you remember we said Flags is alternative for Argo CD? So Flagger is the alternative of our rollouts as well. So if you use Flags for your GitOps, and that watches all the resources and so forth, then use Flagger, which is similar functionality to Argo rollouts. So it depends. These are two competing. I think there are two different companies. I'm not aware of this, but they are similar tools. So I haven't had enough time to look into Flags and Flagger. What I could see is that they are quite similar. So, and if you go with Flags, go with Flagger. If you go with Argo CD, go with Argo rollouts. It wouldn't make any sense using Argo rollouts and Flags, for example. Okay, so check both of them. And then Spinnaker was the first tool I heard about continuous delivery, right? And it has lots of features, but my opinion is this a bit more complicated to use and set up. But again, if you are a Spinnaker user, you may disagree with me. So it's again, that's again depends on each tool. Again, tooling is controversial. Okay, let's move to my new favorite tool. Well, I get excited about a tool, and then I have another favorite tool. So, but this one is my new one, new favorite tool. So it's CrossPlane. It's still on its earliest days, right? But for me, one problem I have is everyone knows, but lots of people work in the cloud, right? So you work in AWS, GCP, or Azure, or whichever cloud you use. and you are running Kubernetes, it's super efficient. You're running Kubernetes very cost efficient. You have node pools with spot instances, which to run my high available service that they can go down. It's okay, very cheap. You have everything, but sometimes like running complicated things, even stateful things like a Cassandra cluster, a Kafka cluster, or even an optimized Postgre database. That's why everyone say, oh, don't run a database in Kubernetes. Well, depends on the database. There are databases that run well on Kubernetes, right? Like Cassandra could run well if you basically set up properly, using CPU pinning and local SSDs and so forth. There are ways that you can run databases in Kubernetes, but sometimes it's not even worth the hassle of maintaining a Kafka cluster or a Cassandra cluster, and you may use a cloud service instead. Like, for example, DynamoDB is an amazing database that AWS has. Bigtable is another one I use. It's quite cheap and works really well. So you may want to use some of these services, and now you get into this confused state of, okay, now I have Argo CD, I have everything in GitOps, but then I have these external services that are managed and have a completely different life cycle, right? And you tend to, of course, use Terraform and to create those environments, but then DevOps gets, messy, because now you have a repo with your infrastructure and your code. And again, I'm fan of having everything together. So if I run microservices, my microservices defines also the infrastructure that it needs. And now it's very complicated, because now I need a RDS instance or Cloud SQL instance, and that's managed by elsewhere. It's really complicated. So CrossPlane tries to solve this issue of, if you create a deployment file YAML to create a service, or Argo workflow definition to create a batch job, if you want to create a RDS database, you also use a YAML definition. So it uses, again, custom resource definitions, like all these tools, and to spin up third-party services, especially cloud services, right? So now it solves this issue that you can have everything in code. Argo CD can watch it. And it's really cool, because Argo CD could watch that definition. You have your YAML file defining, I want a cloud database, right? And Argo CD watches that repo and then creates that database in AWS or in GCP, right? So it manages the third parties, and it still is a control loop, meaning that if you go to the console and you delete the database, after a few minutes it's back up, because basically Argo CD is watching that and recreating, and CrossPlane is also monitoring the resources. So when they say that, Terraform, in Terraform, you cannot achieve this level, right? In Terraform, you will need to run the pipeline again, do Terraform apply. Terraform will tell you the difference, that shift between drift on configuration between production and the source code, right? So yeah, infrastructure code is great, Terraform is great, but it's not constantly watching, right? You need to run the pipeline, and then Terraform will tell you, okay, there's a drift, click apply, and now it's matching the source code, right? But with CrossPlane, it's actually always watching, right? So if something happens in production, you don't need to run CrossPlane apply, right? It's actually always like Kubernetes does. When you delete a pod, it will create another one, because you specify 3 replicas. So this is really cool. It's actually bringing Kubernetes extending to the third party. So for me, it's finally the bit I was missing, right? So now I don't need Terraform to create resources. I do everything in YAML, and using GitOps principles and integrating with Argo CD. For me, this is amazing. The only price CrossPlane is still early stages. Like for AWS, you can have lots of resources. GCP has less support, and Azure even less. So not all the services, AWS has over 200 services, and not all of them you can create with CrossPlane, but they provide a nice API. And especially if you work in a company, you want to contribute to this project, please do, because I think it has a lot of features, and it's very easy to add a new service to it. And so you can, if you are interested, play around. And if a service, I don't know, for example, imagine that Kinesis is not there, I'm not sure, you can add a plugin and use this. But again, it's an awesome tool. For me, I love Terraform, But when CrossPlane is more mature, I don't see myself using Terraform anymore. And that's an alternative Terraform. Pulumi is another one, if you haven't heard, it's an alternative to Terraform, but it uses basic programming language instead that complicated. Well, complicated, no, I love Terraform language, but it's because of the declarative nature, it's harder to test, right? So if you want to do tests on your infrastructure as code, look at Pulumi, it's quite interesting. But if you can do it with CrossPlane, do it with CrossPlane is the best choice. But again, be aware that it's not super mature project yet. So, but I see a lot of future. Okay, just conscious of time. Again, here, Knative, there's OpenFast and a few other things. Serverless is awesome, right? I use it many times. I have a talk, so if anybody's interested, I did a talk last year a lot comparing serverless and Kubernetes. This is a huge topic. For me, both are similar and the level of abstraction is different. But if you're interested, let me know or get in touch with me. And I have another article. Again, go to my articles and see the difference. But the problem with serverless and AWS Lambda is that it's very tied to the cloud provider, right? So it's very hard to do a cloud agnostic or cross-cloud hybrid thing, serverless deployments, right? But in Kubernetes, if you are really invested, right, into Kubernetes, right, because you want to run in any cloud and be completely cloud agnostic, but you want to have this type of event-driven applications based on functions, then you'll use Knative to run functions. So basically, it's abstraction over on top of a pod to run really short-lived tasks that react to events. And actually, there's a overlap here with Argo events because Argo events could react also to something uploaded in S3 and run. So in terms of that, there's a bit of overlap, but Argo events runs in a normal pod. There's no abstraction over that pod, but both are similar. So if you want to run functions as a service on top of Kubernetes, look at Knative or OpenFast as well. It's another alternative. Again, for me, it's those questions. Remember that we with Bart, we were talking about how do you choose one tool or the other? Well, it depends on your company. So your company is investing in AWS and is so investing in AWS that there's no way they're going to move from AWS. Then don't go and implement all this thing in Kubernetes. Just use serverless AWS Lambda, and that's fine. I'm totally, I love serverless, but for me, it's very hard to be cloud agnostic, right? And some companies need to be deploying any cloud. So in that case, Knative is great. Okay, sorry, there are a lot of tools. So, but we're almost done, I think. And then hopefully we'll have some time for short Q&A. I'm sorry, of course, I don't have time to demo all these tools. So maybe later, let's go in the wait for the Q&A. If people is interested in seeing any tool in particular, then maybe we can organize something and do a demo of a specific tool. Anyway, moving to Kyverno, one thing that always happens as in large organizations is that you need to control what developers do. So for me, I'm really open to, things should be independent and all that, but there are certain things you need to enforce, especially for security reasons, and to make sure that somebody goes and basically start using all the resources in the cluster. Everyone, probably you are familiar with resource and quotas and how to manage that in Kubernetes, but also network policies and so forth. But that's basically the problem is very hard to manage, right? So Kyverno basically is a policy engine, right? People who use Open Policy Agent may be familiar with similar. It's a way to set policies on a cluster, right? But Kyverno, again, is GitHub friendly, it's native to Kubernetes, it's based on YAML, so no new language is required, like Open Policy, where there has this rules definition that you need to learn. With Kyverno, you use regular YAML that you are familiar with in Kubernetes to write policies. And they can validate all types of, even mutate Kubernetes resources. So even basically imagine that you create a deployment that has root access. So it can even deny it, or it can even change that. You can even set the rule that mutate and remove that root access, right? It can also have audit mode, so you can decide to stop this user trying to deploy this, or just audit and you will get notified, right? So you can audit these policies, especially as you implement them. You can audit first on the first wave. You set up the rule. You see if anybody's, have a rule that is breaking this new policy. And if that happens, then you can notify the team, and the team can change it, and then you move to the enforcement level where you don't allow any users to use that. And that's to avoid, again, this, networking issues and security. So if you want to have policies so two namespaces cannot talk to each other, you can enforce that as well. Again, the alternative is Open Policy Engine, but Open Policy Engine is not Kubernetes friendly or GitOps friendly. That's the problem, but it's more famous as well. The next thing is related to the open application model. At the beginning, I did mention that I like the abstraction of Kubernetes because it allows to build lots of tools, and it's quite low level, right? So the problem of Kubernetes is not that easy to get started. It's a complicated, basically, a tool to learn, especially because of this low level that you need to understand taints and toleration, network policies, volumes, the Kubernetes networking, how it works. But most of the time, developers, they just want to build applications and deploy them and don't think about all these issues, right? Oh, do I have enough resources? Oh, do I need to have auto-scaling? So the open application model was created to overcome this problem. And the idea is to create this higher level of abstractions around applications, right? Which are independent of the runtime. So it's abstraction on top of Kubernetes, but it could be on top of anything. So you can, it's not even native to Kubernetes. It's a way to say, okay, I can deploy anything the same way, whether it's in Kubernetes or not, right? And Kubernetes is an implementation of this open application model. If you haven't heard it, again, all these things that you see in the slides, there are links. So we'll send it after, and you can click and read about it. But if you are working a big company that is invested in Kubernetes, you probably notice this friction that developers need to learn a lot. At the end, they don't build fully a cloud-native solution. For example, in Kubernetes, if you build a service, it has to be self-healing. You cannot just connect to the database, and if it's not there, fail, because in Kubernetes, the database pod could have been deployed after yours. So you cannot rely on time kind of things. So you need to build your software different, and it's complicated. So if you just want to build applications, the open application model is very interesting, especially for large applications. And the way it creates abstraction of in Kubernetes applications are first-class citizenship. Is a resource in Kubernetes, like you have a deployment or you have a pod, you have now applications. Again, everything implemented in YAML, GitOps friendly. Everything that I've been saying is GitOps friendly because it's YAML, it's configuration, and can be stored in Git or any code repo. And the idea is you have the platform team and the application team. The platform basically manages the cluster, right, and the different environments, the defined components, anything that could be deployed. It's a component, like, for example, a Helm chart. So this platform team create Helm charts and then create traits. So a trait is basically to alter the behavior. So for example, a component will be a microservice, and a trait could be auto-scaling, right? So, and then as a developer, as you go and say, I want an application that, I'm interested in auto-scaling. So I take that trait, right? And developers define this application by assembling the components and traits. So that's the application model. It's really cool, really interesting. And definitely check it out for bigger things. But as I mentioned, for me, I'm not too convinced of this model, because for me, I think the level of abstraction of Kubernetes is quite right. I know it's awful that you have to learn so much, but I've been in many cases, especially dealing with machine learning tools and things like that, you really need to know how Kubernetes work. And some examples are the ones that I'm talking about, that, for example, if you have a Go microservices that is completely stateless, you may want to run this in spot instances to save money. So you need to know how taints and toleration or node selector works, which in Kubela it will be hidden. So it will, for the cluster operator, wouldn't know if that should run on spot instances. They wouldn't know, there are a lot of things that you really need low level, especially to optimize cost and security, right? So that's why I think for me, this is, for a real world usage, is too high level, because you just think of a normal hello world type of microservices, but then there are services like Elasticsearch that, in Elasticsearch you have hot nodes, warm nodes, cold nodes. It's much more complicated because you will have different node pools and different workers in Elasticsearch will run so in different type of node pools. So you need to add this extra configuration. So in real world, you have this advanced settings in Kubernetes, like you may want to have local SSD here, so CPU pinning enabled to this. So it's just too high level for me. The thing will work for normal applications, but I don't know of any big company that has implemented this model. And if anybody knows, please let me know, because I wonder how this could work. And the only reason why I put this is because it's GitOps friendly, and because I think companies trying to achieve the same thing as here, creating these high-level abstractions, starting by creating a Helm chart for all people to use. Oh, this is a microservice Helm chart. Now everyone goes and use it, right? And then they become very expensive because they all run using the same resources. And so if you are a DevOps guy trying to build towards this by creating tools that enforce network policies, all things like that, make sure you check Kubela, because probably you are more or less trying to achieve what Kubela does. But be careful. I'm always more inclined to have everyone in the organization have a good level of Kubernetes, or at least per team have a Kubernetes expert, than then going to this higher level of abstractions that then may not fully work. But that's my personal opinion. Anyway, for alternatives to Kubela, Shipa is one that I had a look. It looks similar to me, but I haven't played around with it. So if anybody knows it or have played with Shipa, I think the problem is if Shipa, you have to pay for it. But let me know. And of course, I forgot to mention I think all of these tools are open source. Okay, so that's why Shipa didn't put it there. And then Cage, it's another tool that it was recommended for me after I created the article, but it's using mainly command line interface to deploy applications. So with Cage, it's really easy using Cage to deploy in Kubernetes using command line, but again, that's not GitHub friendly, right? So that's why it's not there on the list. Think I put it there again to answer the question. So how mitigate security and compliance and all that in Kubernetes, then use this tool. I haven't used it myself, so if somebody's using it, again, feel free to contribute. And Falco is another tool that can check threats at downtime. So for security, just check these tools, and that will answer the question how I monitor possible threats for my applications running Kubernetes. Then you use these tools. Okay, we're almost done. The last tool is, I think it's the last one. No, we have two more, sorry. So DevSpace is a development tool for Kubernetes. You should go, it's hard to demo here in a slide, but this is another tool I recommend. Just install and play around with it because it's really fun. It's for you to actually develop in the Kubernetes way. So one thing that I usually do in Kubernetes is actually to use Docker locally, So I have a Docker Compose file, and then I have my Helm charts and my definitions and so forth, right? But there's a gap, like especially because different environments like Windows versus Linux and so forth is not the same, right? So you run your application in a pod that you have a Docker file, and then you have a different environment for local development. So dev space, the most important thing is that it has this hot reloading. So that means that dev space will launch a pod locally in your laptop with your code and will watch the files. So as you code, like you're changing your Python files to JavaScript files, the change will be copied to the pod. So you are running actually an actual pod in actual Kubernetes cluster using the Kubernetes ecosystem, but having that really nice developer experience, right? With the confidence that it's going to run the same way in production. So it's really, really cool tool. Again, I haven't tried with compiled languages. I don't know if it will work with Go or C++. If you have used it, please mention it in the Q&A. And the next tool is what happens if you have a relational database and you need to handle schema evolution, changes on the database. Many of you probably heard of Liquid-Base is the most famous alternative, but again, not Kubernetes friendly, not GitHub friendly. Schema Hero is your solution. Again, you use YAML, you use Kubernetes resources, and you can manage the desired state. So again, it's declarative in the nature that it will compare your database against your definition in your source code and basically manage any drips on the configuration. Again, you can use Argo CD and perfect. So Schema Hero for databases. Another thing, if you're probably thinking, oh, GitHub is great, I can put everything in Git, but I cannot put a credential there, right? That's why we have vaults, right? To store this credential, rotate them, your keys, your API keys, and all that. But then you create this thing. Everybody's aware of Kubernetes secrets that basically, well, as long as you control access to the ETC database, they are there and perfect. You can consume mounted in your pod, and it's awesome. Secrets are awesome. But how do you get the secrets into your Kubernetes cluster? If we use GitOps, you want to have all the resources, deployments, everything in YAML. And your Kubernetes secret is another Kubernetes resource that also is YAML, but you don't want to put that in Git because it's secret. Again, Seal Secret is used to do that. There's also Kubernetes native has a control loop, and basically you can have in Git now your secrets. So you have your secret definition, in case it's called Seal Secret, which is fully encrypted and secure. You have it in source code whenever you deploy it. So you can use Argo CD as well, and you say, okay, this is my secret. And what it does, the controller looping in the cluster will detect, oh, this is a Seal Secret. Now I can securely decrypt it and convert this Seal Secret into a normal secret. And now I can have everything in source code, GitOps principles. The alternatives are not GitOps principle. I use SOAPs in the past. Actually, because of that, my CI/CD pipeline needs to call SOAPs, decrypt, and then create the secret in Kubernetes. But you have to have that step, right, where you yourself have to manage that, which is not ideal. Get the secret from the vault and then decrypt it. So again, have a look to Seal Secrets. And okay, we have 2 minutes. So one thing again is multitenancy. So many companies they have to have a cluster per customer, for example, and that's super expensive. And they end up doing these custom things where they have namespaces, but namespaces, they are just logical partitions. They are not fully isolated. They are not secure. So they end up implementing network policies, super complicated stuff. So this is some problem that is now in Kubernetes that is hard to have multi-tenancy. They are working now on the hierarchical namespaces, which is still in alpha release, I think, to overcome these issues. But the idea is to have a parent namespace per tenant with common network policies and quotas for the tenants, and then allow the creation of namespaces, child namespaces, right? So you create your hierarchy, and then you could have a bit of multi-tenancy by having this hierarchy. But it still is not, they call it hierarchical namespace and not multi-tenancy because it's not there. Anyway, so Capsule is a tool which provides native support for multi-tenancy. So basically, in a single cluster, you can have multiple customers that are completely isolated, right? They will use the cluster like if the cluster was their own cluster, right? There is just some minor restrictions, right? For example, they won't be able to create a namespace, so they will notice that they will get an error. So because actually that's managed by Capsule. But basically, it's hidden the fact that the cluster is actually shared, which is great. And of course, zip-top friendly because it's all managed by YAML and configuration that can be stored in Git. And go another step further is Big Cluster, which can be used for multi-tenant. It offers multi-cluster. This is really cool. Have a look to it. But basically, its cluster runs on a regular namespace and it's fully isolated. Actually, what it does behind the hood is actually, remember K3S that we talked is a very lightweight version of Kubernetes. So basically uses that service to make virtual clusters super lightweight, right? And then you can use kube context to access the virtual cluster. So the cluster actually creates a fully compliant, because it uses K3S API, cluster on top of your real clusters. Okay, so it's like it saves you loads of money, right? Because you have the control plane is the same, and you can have a huge cluster with all your customers. So definitely for multi-tenant, have a look. And then when you want to compare with Capsule, just think that basically the cluster offers a lot more because it's not only for multi-tenant. You can use it for test dev environments, but it uses a bit more resources. You can read about the cluster, but it's very efficient, but it still uses a bit more resources because you have a virtualization on top of that. And then finally, the list of tools that didn't make it. Again, I go now really quick. Kube Apps is basically like a store, right? Where you can, it's a web-based UI where you can select applications. It's very good to create your list of apps for your organization. Kubesphere, it's a huge project. I don't want to get into that. It has a nice UI. It basically allows you to manage clusters, users, applications. It's a whole different thing to think about Kubernetes. Like it has a lot of integrations. It has a store app, and you can do pretty much everything. You can create clusters, users, and all that. But for me, it does not follow the GitOps principle, and it's very resource intensive. So I didn't consider it. But to have a look to it is very interesting project. For me, it's like under the hood is all based on Ansible. So if you are running Kubernetes, why are you using that? It just didn't make much sense to me. So. But I didn't spend much time looking at it. But definitely it's a huge project, have a look. And then you have tools, if you want to do X in stress testing, use Kubernetes. If you want to use chaos engineer to random fail, use Litmus. If you want to monitor and have push notifications on Slack about something that happens in Kubernetes cluster, use KubeWatch. Bot queues is for messaging, for having bots, similar to KubeWatch as well. And then Mitsu is for at API traffic viewer, similar to Kiali. Kiali is using, it comes with Istio to monitor the traffic, but Mitsu is just on API traffic. And then Kubefledge, it's basically an interesting tool. So I must have just install it, and basically creates a cache for your images in your nodes in the cluster. So then the image is cached there, so it doesn't have to go to your registry to download the Docker images, right? So that will save you time, and the pods will start almost instantly, which is really cool. So Kubefledge, nice to have, use it when possible. Oof. So I think I'm done. Sorry, I'm a bit over time. So those are lots of tools. So I will send the slides. Just have a look, read the article, and hope this at least caught your interest.
Oh, I think it definitely did. We got first of all, you did an amazing job. I can't believe you were able to get through all of those so quickly. But just looking at a couple of questions that I'll share in the chat here on Zoom. We had a few of these here. So the first one, Octant is also a good alternative to Lens. Are you familiar with that one?
No, so that's another one, but very good. I haven't look into Octane. So what I'll do is I'll have a look and probably update the article. So thanks.
No, that's good. I think because the thing is like, because being the CNCF and our community is integrated in the CNCF, very often the CNCF landscape gets very overwhelming. But I think also the tooling landscape, I think there's something that can be, maybe worked out here is creating like a visual map for all these different tools, because it's growing every day, like and new versions get released and things like that. Next question, is it possible to spin up an environment to test branches using Argo CD? And what would be a good way to go about it?
Yes, so it's possible. Again, all it does is watch a certain repo, right? So the way usually it's set up, again, is you create a repo per environment, and then you point it to some other repo. So actually, you start creating this thing where you watch another repo, right? Mm-hmm. And then you can set up rules like, again, to be a specific branch or master branch. So that's possible. Again, it will depend on your branching strategy, right? But Argo CD supports basically watching your main branch or any other branch.
Very good. Then we had another question here. Have you had a chance to use Scaffold or something similar in development? What's your opinion on that?
Yes, I used it a long time ago. That's a good point. I should have included in the article. And I think it should be an alternative to DevSpace, right? Because it is for your, as far as I remember, Scaffold, and correct me if I'm wrong, it's for that development experience, so you can develop easily from local to your production cluster, right? And so that way it will manage the building of the images and so forth. And I think I didn't consider because as far as I know, it was not so GitOps friendly, but definitely I should have added as an alternative. But whoever asks if, wants to add anything, that will be appreciated. But yeah, I will add it to the article as an alternative.
Very, very good. Cool. Just for the sake of time, I really appreciate all the folks who stayed to the end for the questions. That being said, Javier, for people that have other questions or would like to contact you, what's the best or easiest way to do that?
To contact me, I would say either, Twitter or LinkedIn, any of the two. And of course, to stay up to date with my articles, because at least I write an article one per month. Just subscribe to my articles. There's a link, and you can subscribe so you get notified when I publish one in medium.com. And that's it. And then, of course, feel free to reply to the articles. It's especially if you know of another tool, because I think this article is being shared a lot and becoming like a reference for many engineer managers and things like that. So I want to make sure I don't miss anything. So those tools, Octane and Scaffold, should be mentioned there. At least my idea is that you have one place with all these tools where you get an idea of, at least to have options. I try to be, as I said, besides being GitOps friendly, then I don't have a strong opinion on any of the tools.
Very, very good. Anyway, no, we're just getting really nice feedback, comments in the chat. Javier, can I get you to stop sharing your screen really quickly so that I can share mine?
Yeah. Done.
Okay, very, very good. So while you were talking, as usual, we have a wonderful artist who's working with us. His name is Angel. He goes by Ardiluthu. And so he created a nice visual summary. Let me know when you can see my screen. Can you see it? Can you see my screen? Yes, maybe. Can you see it?
Oh,
yes.
This is awesome.
Yeah. So anyway, Angel's awesome. Big shout out to Angel. He's doing a great job. And so, yeah, so obviously there was a lot of stuff to cover in there, but while you were talking, he put that together, a nice visual summary of the different things that were being mentioned. I think this is incredible. I mean, writing blogs isn't easy. Putting yourself out there, you can get attacked. I think there's a lot of courage that's involved in that. I think a lot of people can learn from that as well, too. Obviously, the research that you've done to get all these tools out there, I can't even imagine how many hours have gone into this presentation, the blog post, but I think it's a really good example of what people can be doing on their own while they're interacting with this stuff, documenting their journey. So like you said, that is not so overwhelming. And I really like this concept of accidental complexity. You should write a book with that as the title. I think that'd be really cool because it seems to happen. I think it's a really good point that a lot of people would agree with. Anyway, Javier, I learned a lot today. It sounds like our audience did as well. We're definitely going to continue to follow your articles. Please let us know when you're writing something new and we'll be happy to share it. And thank you very much for your time. Thanks to everyone who joined us in the audience. If you want to continue the conversation, I linked Javier's Twitter. Also check him out on Medium. You got the link to the article at the beginning of the session as well. So please, let's keep this going. And hopefully we'll be having you back the next time you write. So thank you very much for all your hard work.
Thanks for having me.
My pleasure. Everyone. All right, take care. Bye-bye.